wabarakatuh. Hello everyone, welcome to our learning session today. But first of all, let me introduce myself. My name is Ambar with student numbers A1324021. In this video, we're going to talk about geometric transformation. It's a fascinating topic and I'll break it down for you step by step. So check it out and let's get started. So, what is geometric transformation? Transformation is a change in position, and geometry is something related to points, lines, or planes. So, geometric transformation is a change in the position of a point, line, or plane. In studying geometric transformation mathematics, the initial position of a plane is denoted by x, point y, and the final position is denoted by x-axis, point y-axis. Okay, there are 4 types of geometric transformation as follows. First, translation, second, reflection, third, rotation, and fourth is dilatation. But on this occasion, I will explain about reflection and rotation. Okay, first is reflection. Reflection is a transformation that moves points on a plane using the mirror image properties of the points to be moved. In the reflection transformation, the distance of the point in the image shape to the mirror axis is the same as the distance of the point in the original shape to the mirror axis, but the image faces in the opposite direction. In reflection, translation may also occur because of changes in the position. Here, the original image is called pre-image, and its reflection is called the image. The representation of pre-image and image are A, B, C, and A accent, B accent, C accent, respectively. The reflection transformation may be in reference to the coordinate system, X and Y axis. Okay, there are 8 types of reflection. First is reflection on the x-axis when a point is reflected across the x-axis. The x-coordinate remain the same, but the y-coordinates are transformed into their opposite sign. The image is like this, and this is matrix transformation for reflection on the x-axis. Okay, first is determine the coordinate of the image A 30, B 51, and C 45 when reflected on the x-axis. Remember the reflection of pxy, the p-axis is x point minus y. So A 3.0, the A accent is still 30. B 51, the B accent is 5 point minus 1. C for 5, the C accent is 4 minus 5. Next, number 2, determine the result of reflection y equal to x plus 3 when reflected on the y-axis. In fact, we can use the direct method like number 1. But for number 2 and 3, we will try the matrix method. From the matrix, we know that x equal x accent and y equal minus y accent. And then we substitute it into y equal to x plus 3. We get minus y accent equal to x accent plus 3. So the reflection is minus y equal to x plus 3 or 2x plus y equal minus 3. Okay, number 3 is determine the result of the reflection x squared plus y squared minus 2x minus 8y minus 16 equals 0 when reflected on the x-axis. With matrix, we get x equal x-axis, y equal minus y-axis. Sorry, I have mistake. It's supposed to be minus y-axis. So x squared plus y squared minus 2x minus 8y minus 16 equals 0 is x-axis in bracket squared plus minus y-axis in bracket squared minus 2x-axis minus 8 minus y-axis in bracket minus 16 equals 0. The reflection is x-axis squared plus y-axis squared minus 2x-axis plus 8y-axis minus 16 equal 0. Next, second is reflection on the y-axis. When a point is reflected across the y-axis, the y-coordinates remain the same, but the x-coordinates is transformed into its opposite sign. Therefore, the reflection of the points x, points y across y-axis is minus x, points y. The image for reflection on the y-axis is like this, and this is the transformation matrix. Okay, for example, if I have 3 points, point A 5, 3, point B minus 2, 2, and point C minus 4, minus 4, and they are reflected by y-axis, a-axis is minus 5, 3, b-axis is 2, 2, and c-axis is 4, minus 4. Third is a reflection on the line x equal y. When a point is reflected across the line x equal y, the x-coordinates and y-coordinates change their place. Therefore, the reflection on the point x point y across the line x equal y is y points x. The image for reflection on the line x equal y is like this, and this is the transformation matrix. For example, if we have point A 2, 5, B minus 2, 6, point C minus 4, minus 2, and reflected by y equal x, a-axis is 5, 2, b-axis is 6, minus 2, and c-axis is minus 2, minus 4. Fourth is a reflection on the line y equal negative x. When a point is reflected across the line y equal negative x, the x-coordinate and y-coordinate change their place and are negative. Therefore, the reflection of the point x point y across the line y equal negative x is negative y point negative x. The image for reflection on the line y equal negative x is like this, and the transformation matrix is like this. For example, if we have point A 5, 2, point B minus 2, 6, and point C minus 4, minus 2, the reflection on y equal minus x is a-axis minus 2, minus 5, b-axis minus 6, 2, and c-axis 2, 4. Reflection on x equal h. Reflection across the line x equal h is a transformation where each point of a shape or object is mirrored over the vertical line x equal h. The distance from any point to the line x equal h is preserved, but the direction of the distance is reversed. The new point will have the same y-coordinate as the original, but the x-coordinate will be symmetrically opposite relative to x equal h. Mathematically, if a point is x point y, its reflection across x equal h will be 2h minus x point y. The image for reflection on the line x equal h is like this, and this is the transformation matrix. Okay, for example, if we have point A 5, 2, point B minus 2, 6, and point 3 minus 4 minus 2 reflected on x equal to, the A axon is minus 1, 2, B axon is 6, 6, and C axon is 8 minus 2. Okay, 6 is a reflection on y equal k. Reflection across the line y equal k is a transformation where each point is mirrored. Over the horizontal line, y equal k. The distance from any point to the line y equal k is preserved, but the direction of the distance is reversed. The new point will have the same x coordinate as the original, but the y coordinate will be symmetrically opposite relative to y equal k. Mathematically, if a point is x point y, its reflection across y equal k will be x point 2k minus y. The image for reflection on the line y equal k is like this, and this is the transformation matrix. For example, if we have point A 5, 2, point B minus 2, 6, and point C minus 4 minus 2, reflected on y equal 1, A axon is 5, 0, B axon is minus 2, minus 4, and C axon is minus 4, 4. Okay, next is reflection on a point. A reflection point occurs when a figure is constructed around a single point known as the point of reflection or center of the figure. Now, for every point in the figure, another point is found directly opposite to it and the other side. 7. Reflection at the origin 0.0 refers to a type of transformation where each point of a figure is reflected across the origin of the coordinate plane. Therefore, the reflection at the point x point y across the origin is minus x point minus y. The image from the reflection at the origin is like this, and this is the transformation matrix. For example, if we have point A 5, 2, point B minus 2 minus 4, and point C minus 4 minus 4, reflected at the origin, A axon is minus 5 minus 2, B axon is 2 minus 4, and C axon is 4, 4. Okay, A is reflection at the point RAB. Reflection across the point RAB is transformation where each point is mirrored over the point R. The reflected point is equidistant from R as the original point, but lies on the opposite side of R. To find the reflected point, we double the coordinate of R and subtract the coordinate of the original point x point y. Mathematically, if a point is x point y, its reflected across RAB will be 2a minus x point 2b minus y. The image for reflection at point RAB is like this, and this is the transformation matrix. For example, if there are point A 5, 2, point B minus 2, 4, point C minus 1 minus 2 reflected at point D 2, 4, A axon is minus 1, 6, B axon is 6, 4, and C axon is 5, 10. Now, after discussing reflection, let's now move on to another important transformation in geometry, rotation. Rotation is a form of transformation by rotating an object based on a certain angle and direction toward the center of rotation. The direction of rotation counterclockwise is positive. Conversely, the clockwise direction of rotation is negative. The most common rotation angle are 90 degrees, 180 degrees, and 2070 degrees. There are two types of rotation. First, rotation with center point at the origin and rotation angle alpha. If point A, x, y is rotated by the center O, 0, 0, and the result of the rotation is x-axis, x-axis, y-axis, then the vector x-axis, y-axis equals the product of the 2 by 2 matrix with cosine alpha and negative sin alpha in the first row and sin alpha and cosine alpha in the second row multiplied by vector xy. The formula is like this. Okay, for exercise, determine a-axis, x-axis, y-axis, which is the result of rotating point A 5, 2 at the center O 0, 0 by 90 degrees counterclockwise. Okay, we write the matrix formula. The alpha is 90 degrees and we substitute 90 degrees into the formula and we get cosine 90 degrees is 0, negative sin 90 degrees is minus 1, sin 90 degrees is 1, cosine 90 degrees is 0, multiplied 5, 2, so we get minus 2, 5. Second, rotation with center PAB and rotation angle alpha. If point A, xy is rotated by the center point PAB and the result of the rotation is a-axis, x-axis, y-axis, then the vector x-axis, y-axis equals the product of the 2 by 2 matrix with cosine alpha and negative sin alpha in the first row and sin alpha and cosine alpha in the second row, multiplied by vector x minus a, y minus b, plus vector ab. The formula is like this. Determine a-axis, x-axis, y-axis, which is the result of rotating point A 5, 2 at the center P 1, 1 by 90 degrees counterclockwise. So the x is 90 degrees, the x is 1 and the y is 1. And then we substitute into the formula and we got cosine 90 degrees minus sin 90 degrees, sin 90 degrees, cosine 90 degrees, multiplied 5 minus 1, 2 minus 1, plus 1, 1. So we get 0, minus 1, 1, 0, multiplied by 4, 1, plus 1, 1. So we get minus 1, 4, plus 1, 1. And we get 0, 5. And this is the illustration. Alright, this is for today's video. Thank you so much for watching and I hope you found it helpful. If you enjoy it, don't forget to give a thumb up. And you haven't already, make sure to hit the subscribe button and turn on the notification bell so you don't miss any future upload. Get any thought or question? Drop them in the comment below. I love to hear from you. Thanks again for hanging out and I'll see you in next video. Bye!